You're watching China intentionally release 5 billion mosquitoes into its cities every single week, and what happened next completely rewrote the rules of fighting disease. This wasn't a mistake or an accident. This was the most counterintuitive solution to a crisis that was killing people and crippling entire cities. The mosquitoes themselves were engineered in ways that sound like science fiction. The scale of the operation is almost impossible to comprehend, and the results shocked every health expert on the planet. What you're about to discover is how China turned humanity's deadliest enemy into a precision weapon. But to understand why they did something this radical, you need to see the nightmare they were facing. Imagine waking up with a fever so intense your body feels like it's burning from the inside out. Your muscles ache like you've been beaten with hammers. Your head pounds with pressure that makes you want to scream. Then, the rash appears, spreading across your skin like wildfire. You can't eat, you can't sleep. You're rushed to a hospital that's already overflowing with people suffering the exact same symptoms. This was the reality for thousands of people in Guangzhou, China, every single year, and it was only getting worse. Dengue fever had turned southern China into a war zone, and the enemy was winning. Every summer and fall, the city of Guangzhou, home to 15 million people, braced for an inevitable outbreak. Thousands were hospitalized annually. People died. Children, elderly, healthy adults. Dengue didn't discriminate. The disease spread through a single species of mosquito called Aedes albopictus, and this tiny insect had become virtually unstoppable. Here's what made this mosquito so terrifying. It didn't just live in jungles or swamps like other disease-carrying mosquitoes. Aedes albopictus thrived in cities. It bred in the tiniest pools of standing water, a bottle cap, a forgotten flower pot, a clogged drain, a construction site puddle. In a dense urban environment like Guangzhou, there were millions of these breeding sites, and eliminating them all was physically impossible. You couldn't just drain a city. And this mosquito was aggressive. Unlike malaria-carrying mosquitoes that only bite at night, Aedes albopictus attacked during the day. It followed people indoors. It bit through clothing. Mosquito nets were useless. Staying inside was useless. If you lived in Guangzhou, you were a target the moment you stepped outside, or even if you didn't. The Chinese government threw everything they had at the problem. They sprayed pesticides from trucks driving through neighborhoods, coating entire districts in chemical fog. It didn't work. The mosquitoes developed resistance, bouncing back stronger after each spraying campaign. They launched massive public education programs, teaching citizens to eliminate standing water and cover their skin. Compliance was impossible to enforce, and even one negligent household could breed thousands of mosquitoes. They tried insecticide-treated materials, genetic traps, biological controls. Nothing made a dent in the population. Every failed attempt cost millions of dollars. Every failed attempt meant more people in hospitals, more families destroyed by a preventable disease, more children missing school, more workers missing jobs. The economic toll was staggering, not just in direct healthcare costs, but in lost productivity as entire neighborhoods fell sick simultaneously. Guangzhou was one of China's economic powerhouses, and dengue was bleeding it dry. But the human cost was worse. Picture a mother watching her 5-year-old daughter's fever spike to dangerous levels, knowing the hospital is already full. Picture elderly patients whose bodies can't handle the hemorrhaging that severe dengue causes. Picture the fear that gripped the city every time mosquito season arrived, because everyone knew someone who'd been hospitalized, and everyone knew someone who hadn't made it. Scientists understood the problem perfectly. As long as Aedes albopictus could breed, dengue would spread. But how do you stop a mosquito from breeding when it can lay eggs in a teaspoon of water, when a single female can produce hundreds of offspring, when the climate is perfect for year-round reproduction, and when the city provides infinite breeding sites? Traditional methods assumed you could reduce mosquito populations through elimination, spray them, trap them, remove their habitat. But Guangzhou had proven that in a dense urban environment, elimination was a fantasy. The city needed something that didn't just reduce the mosquito population. It needed something that could crash it completely. Something that would work faster than the mosquitoes could adapt. Something sustainable that didn't poison the environment or require perfect compliance from 15 million people. China was facing an impossible equation. You can't eliminate urban water sources, you can't spray enough pesticide to matter, and you can't change mosquito behavior. The only variable left was the mosquito itself. But what they were about to do would sound absolutely insane to anyone who heard it. Chinese scientists proposed releasing millions more mosquitoes into the very cities being devastated by them. You read that right. The solution to too many mosquitoes was to intentionally add tens of millions more. When the plan was first presented, even experienced researchers thought it was madness. The public would never accept it. The logistics seemed impossible. And yet, it was the only idea that could actually work. But these weren't ordinary mosquitoes. What Chinese scientists were about to engineer would turn the insect's own biology into a weapon against itself. The breakthrough came from studying a bacteria called Wolbachia. This microscopic organism naturally infects about 60% of all insect species on Earth, living inside their cells without killing them. Scientists had known about Wolbachia for decades, but what they discovered about its effect on mosquitoes changed everything. When Wolbachia infects a male mosquito, something extraordinary happens to his reproductive system. His sperm becomes incompatible with the eggs of uninfected females. When he mates with a wild female mosquito, she lays eggs that look completely normal, but they never hatch. They're sterile, dead on arrival. This is called cytoplasmic incompatibility, and it's nature's own population control system. An infected male becomes a biological saboteur, spreading sterility instead of offspring. Every time he mates, the wild population loses a chance to reproduce. If you could flood a city with enough infected males, they would outnumber and outcompete the wild males, mating with wild females and producing nothing but dead eggs. The population would collapse under its own failed reproduction. But there was a complication. When a Wolbachia-infected female mates with any male infected or not, she produces offspring that are also infected with Wolbachia. This meant that releasing infected females could actually backfire, creating a new population of disease-carrying mosquitoes that were even harder to eliminate. The solution had to be male only, and it had to be guaranteed. This is where Chinese scientists made their critical innovation. They would infect mosquitoes with Wolbachia and sterilize them with radiation. It was a double-lock system that made failure impossible. Here's how they engineered these mosquitoes from scratch. First, scientists had to get Wolbachia into Aedes albopictus mosquitoes, which don't naturally carry this particular strain. They harvested the bacteria from donor insects, then used microscopic needles thinner than a human hair to inject it directly into mosquito embryos. These embryos were so small, you needed a microscope to see them, and the injection had to be precise enough to deliver bacteria without killing the developing insect. It required a surgeon's hands and hundreds of failed attempts to perfect the technique. The injected embryos were carefully incubated until they hatched into larvae, then raised to adulthood in isolated chambers. Scientists then bred these infected mosquitoes over multiple generations, testing each batch to ensure the Wolbachia infection rate stayed at 100%. Any mosquito that didn't carry the bacteria was eliminated from the breeding pool. Over time, they created a stable lab population where every single insect carried Wolbachia in every cell of its body. But the Wolbachia alone wasn't enough security. The Chinese team added a second layer of sterilization that would become their signature innovation: X-ray irradiation. They built specialized chambers where adult male mosquitoes were exposed to precisely calibrated doses of radiation. The dosage had to be perfect, strong enough to completely sterilize the insect's reproductive cells, but weak enough that the mosquito could still fly, still mate, still behave, normally enough to compete with wild males. Too much radiation and the mosquito became too weak to mate. Too little and he might still be fertile. Years of testing determined the exact dosage, enough to shred the DNA in sperm cells beyond any possibility of function, but leaving the mosquito's body and brain intact. When an irradiated male mated with a female, he would go through all the normal behaviors, but his sperm was completely inert. Even if somehow the Wolbachia failed, the radiation ensured zero chance of reproduction. It was a double guarantee that made the system essentially foolproof. Now came the challenge of producing only males. Releasing females would defeat the entire purpose. Female mosquitoes are the ones that bite and spread disease. Even a small percentage of females in the release batches could continue the disease cycle. The Chinese team needed near-perfect sex separation, and they needed it at a scale of millions per week. They developed automated sex sorting systems based on a simple biological fact: male mosquitoes are smaller than females. In the pupal stage, when the insect is transforming from larva to adult males, and females are different sizes. The Chinese team built mechanical sorters that could process millions of pupae, using precise size filters to separate males from females. The system achieved 99.9% accuracy. Out of every 1,000 mosquitoes released, only one might be female, an acceptable margin that wouldn't impact the overall strategy. Every batch went through rigorous quality control. Scientists tested random samples to verify Wolbachia infection rates, confirm radiation sterilization, and validate sex sorting accuracy. They tested the mosquitoes' flight ability, their mating behavior, their lifespan. These engineered insects had to be robust enough to survive in the wild, aggressive enough to outcompete natural males, and attractive enough to wild females to ensure successful mating. What made this approach brilliant was that it wasn't genetic modification. The mosquito's DNA remained unchanged. Wolbachia is a bacteria that lives inside cells, and radiation damages existing DNA without altering the genetic code. This distinction was crucial for public acceptance and regulatory approval. Scientists could honestly say they weren't releasing genetically modified organisms into the environment. They were releasing naturally occurring mosquitoes with a bacterial infection and sterile reproductive systems. The safety testing was exhaustive. Researchers verified that Wolbachia posed zero risk to humans, animals, or plants. They confirmed that irradiated mosquitoes couldn't somehow recover fertility. They studied the environmental impact of releasing millions of sterile insects and found no negative effects on ecosystems. Aedes albopictus wasn't a keystone species. Removing it from the environment wouldn't collapse food chains or harm other wildlife. After years of laboratory work, field testing on isolated islands, and safety validation, Chinese scientists had created the perfect weapon: a mosquito that looked, flew, and behaved exactly like a wild male, but spread sterility like a plague. Every mating was a dead end. Every egg laid was a failure. The population would cannibalize itself through normal reproductive behavior. But engineering the mosquitoes was only the beginning. To actually eliminate Aedes albopictus from a city of 15 million people, they would need to produce these engineered insects at a scale never attempted in human history. The Guangzhou facility that Chinese scientists built to wage war on mosquitoes became the largest insect factory on planet Earth. This wasn't a laboratory, this was an industrial production line engineering. 40 million weaponized mosquitoes every single week. And what happened inside these walls was unlike anything humanity had ever attempted. Walking into the facility felt like entering a science fiction nightmare. Massive climate-controlled rooms hummed with precision systems, maintaining perfect temperature and humidity. Thousands of containers held millions of mosquitoes at every stage of development, eggs smaller than grains of sand, writhing masses of larvae, pupae transforming into adults, and finally, chambers filled with clouds of fully grown male mosquitoes ready for deployment. This single building produced more mosquitoes in 1 week than most people would encounter in their entire lives. The production line operated with ruthless efficiency. Wolbachia-infected females laid thousands of eggs daily in isolated breeding chambers. These eggs hatched into larvae within 48 hours and were transferred to enormous rearing pools, each holding hundreds of thousands of larvae swimming in precisely controlled water. Automated feeding systems delivered exact nutrient amounts at programmed intervals. Too little food meant death. Too much meant contamination. After a week of growth, the larvae transformed into pupae. This was where sex sorting began. Specialized machines used mechanical size filters to separate smaller male pupae from larger females, processing millions per day with 99.9% accuracy. Female pupae were destroyed. Male pupae continued down the line into emergence chambers, where within 36 hours they transformed into flying adults, millions of them filling the rooms simultaneously. But before release, every male passed through the irradiation chamber. X-ray machines delivered precisely calibrated radiation doses that completely destroyed reproductive cell DNA while leaving flight muscles, sensory organs, and mating drive intact. The timing had to be perfect seconds of exposure that rendered them permanently sterile but kept them healthy enough to compete with wild males. Quality control was obsessive. Scientists dissected random samples to verify sterility, tested Wolbachia infection rates, placed males with wild females to confirm their eggs never hatched, and measured flight capability. Only batches passing every test moved to packaging ventilated containers that kept millions of insects alive during transport. The entire factory ran 24 hours a day, producing mosquitoes at a cost of fractions of a cent each. The investment was millions of dollars, but compared to endless pesticide spraying and dengue hospitalizations, it was remarkably cost-effective. But producing 40 million mosquitoes meant nothing without strategic deployment. Chinese scientists mapped mosquito density across Guangzhou using monitoring traps, creating heat maps showing exactly where wild populations bred. The data updated continuously, allowing real-time strategy adjustments. Releases happened through multiple methods. Motorized vehicles with timed release mechanisms drove through streets, gradually distributing mosquitoes across neighborhoods. Drones carried containers over high-rise buildings, parks, and areas vehicles couldn't reach. And teams of workers walked door to door through dense housing areas, releasing controlled numbers at specific addresses while logging every location. The mathematics was brutal. Engineered males had to outnumber wild males by at least 5 to 1, preferably 10 to 1. In high-density areas, releases had to be absolutely massive. 40 million per week wasn't overkill, it was the minimum necessary for success. The schedule was relentless. Male mosquitoes only lived 2 weeks in the wild, so new batches had to be released every single week without exception. Miss 1 week and wild males could mate successfully, producing a new generation that would replenish the population. The pressure had to be constant. Public reaction was predictably panicked. Residents saw millions of mosquitoes being deliberately released and called authorities screaming about insect invasions. Social media exploded with videos and complaints. The government launched intensive campaigns explaining that only non-biting males were released, that these mosquitoes were sterile, and that the temporary increase would lead to permanent elimination. Convincing 15 million people to trust the science was almost as challenging as the science itself. Monitoring traps tracked impact in real time. Scientists collected wild mosquitoes and examined whether captured females had mated with engineered males by testing their eggs. If eggs didn't hatch, the strategy was working. If they hatched, wild males were still reproducing successfully. The first month showed barely any change. Wild populations held steady. The engineered males needed time to saturate the environment, to outcompete wild males at breeding sites, to mate with enough females to impact reproduction rates. Scientists urged patience, while residents demanded immediate results. Then, in month 3, something remarkable appeared in the monitoring data. Mosquitoes caught in traps began dropping not slightly, but dramatically. Areas receiving concentrated releases showed wild population declines of 20, then 30, then 50%. The engineered males were spreading sterility faster than wild populations could reproduce. But what happened over the next 9 months would exceed every projection and shock the international scientific community. By month 6, the monitoring traps in Guangzhou were coming back nearly empty. Areas that had caught hundreds of wild mosquitoes per week were now catching fewer than 20. By month 9, some traps caught 0. The Aedes albopictus population wasn't just declining, it was collapsing at a rate scientists hadn't thought possible. The final numbers were staggering. In trial zones receiving intensive releases, wild mosquito populations dropped by 94% within 1 year. Neighborhoods that had been swarming with disease-carrying insects were now virtually mosquito-free. The engineered males had mated with wild females so successfully that the natural population couldn't replace itself fast enough to survive. But population numbers were just data. The real measure of success was written in hospital records. Dengue fever cases in treated areas, dropped by 94% compared to the previous 5-year average. Hospitals that had overflowed every summer with fever patients saw their dengue wards sitting nearly empty. Families that had dreaded mosquito season for years were suddenly living through summers without a single infection. The comparison with untreated areas made the impact undeniable. Neighborhoods just miles away that didn't receive releases continued experiencing dengue outbreaks at normal rates. Same city, same climate, same environment, but completely different disease outcomes. The only variable was the engineered mosquitoes, and that single variable was saving lives. Then scientists discovered something even more remarkable. The population crash wasn't gradual, it was exponential. Each generation of wild mosquitoes that mated with sterile males produced fewer offspring. Those fewer offspring then faced even more engineered males in the next generation, creating a feedback loop that accelerated the collapse. By month 12, some areas had achieved 98% suppression. 2 years after the program began, suppression levels remained stable above 90%. Wild populations had been driven into what scientists called a suppression equilibrium, a state where reproduction rates were so low, the population couldn't grow even under ideal conditions. The releases continued weekly, maintaining relentless pressure that prevented any recovery. The economic analysis revealed the true scale of what had been achieved. Traditional mosquito control had cost tens of millions annually with minimal impact. The engineered mosquito program cost a fraction of that once infrastructure was built. But the real savings came from healthcare costs avoided. 94% fewer dengue cases meant 94% fewer hospitalizations, emergency treatments, and intensive care. The program paid for itself within the first year through healthcare savings alone. Productivity gains added hundreds of millions more. Dengue knocked people out of work for weeks. Every case prevented meant wages earned, productivity maintained, economic output preserved. Multiply that by thousands of cases prevented annually, and Guangzhou's economy was no longer bleeding money to a preventable disease. Environmental impact studies found 0 negative consequences. Removing Aedes albopictus didn't collapse food chains or harm other species. Birds, bats, and fish simply ate other prey. The feared ecological disruption never materialized because this mosquito, despite being a dangerous disease vector, wasn't a keystone species. Its elimination improved human health without damaging the environment. The safety validation was definitive. Wolbachia posed 0 risk to humans, animals, or plants. The irradiated males couldn't recover fertility or mutate into something dangerous. There were no unintended consequences, no unexpected side effects, no catastrophic failures. The engineered mosquitoes did exactly what they were designed to do, and nothing more. International recognition came swiftly. The World Health Organization validated the results and endorsed the technology. Scientific journals published the data. Public health officials from countries facing similar crises traveled to China to see the factory firsthand. Then the technology exploded globally. Singapore launched its own mosquito factory targeting dengue. Brazil, devastated by Zika virus, initiated pilot programs in multiple cities. The United States approved trials in Florida and California against invasive Aedes populations spreading disease in previously unaffected regions. Australia, Indonesia, Malaysia countries worldwide began adopting the model. The applications extended beyond dengue. Aedes mosquitoes also transmit Zika, yellow fever, and chikungunya. The same technology could target all of them. Scientists began engineering other species, including Anopheles, the primary malaria vector. If scaled to fight malaria, it could save hundreds of thousands of lives annually in Africa and Asia. China had done more than solve its dengue crisis. It had created a blueprint for eliminating mosquito-borne diseases that killed over 700,000 people globally every year. Diseases that had plagued humanity for millennia could now be controlled through precision biological intervention rather than chemicals or vaccines. The Guangzhou facility became the template for global disease control infrastructure. Additional factories were built across China, targeting other regions and species. The production techniques were refined and optimized. What started as a desperate solution to a local crisis had become the model for fighting humanity's deadliest animal. The cost-effectiveness made it scalable even in developing nations. Once the initial factory investment was made, per-mosquito production costs were negligible, and healthcare savings far exceeded operational expenses. Countries that couldn't afford endless pesticide campaigns or expensive vaccines could afford to build mosquito factories. The paradigm had shifted completely. For a century, humans fought mosquitoes by trying to kill them with chemicals, eliminate their breeding sites, or prevent disease through vaccines. All had limitations. Mosquitoes developed resistance. Breeding sites were impossible to eliminate in cities. And vaccines didn't exist for many diseases. But turning the mosquito's own reproduction against itself was devastatingly effective because it exploited biology rather than fighting it. 40 million engineered mosquitoes released weekly. 94% population suppression sustained for years. 94% reduction in dengue cases. Hundreds of millions in healthcare costs avoided. Zero environmental damage. Zero safety incidents. A technology now spreading to dozens of countries targeting multiple diseases. China had taken humanity's most dangerous enemy, the creature responsible for more human deaths throughout history than any other animal, and turned it into a weapon against itself. They'd engineered nature at massive scale, proven that the most counterintuitive solution was the only one that worked, and rewritten the rules of fighting disease. The audacity of releasing 40 million mosquitoes to eliminate mosquitoes had seemed like madness, but the results were undeniable, and the world would never fight disease the same way again.